coming up on Home Diagnosis.
Moisture affects pretty much everything that happens in a building and everything that happens in the air.
Your duct system is just plumbing for air.
There's only one best place to put the exhaust fan.
They still today use rules of thumb to select the equipment for your home.
We've turned the whole room into another tool to control the invisible dynamics of our home's performance.
Home Diagnosis is made possible by support from the Alfred P. Sloan Foundation, by Fantech, Breathe Easy, by Brone-NuTone, come home to fresh air, by AprilAire, everyone deserves healthy air, by Air Cycler, Retrotech, and Santa Fe dehumidifiers, by generous support from these underwriters, and by viewers like you.
They say home is where the heart is.
And we certainly put our heart into building our first house, so how hard could it be to build another one?
I'm Grace.
And I'm Corbett.
In our TINYLAB, we helped homeowners gain control of their homes through scientific testing. Now, as we build our forever home, we're testing ourselves.
Even though we know a few things about the invisible dynamics of homes, we're teaming up with scientists and building experts to design and build a perfectly tuned home for our family.
The physics, chemistry, and microbiology of a home might seem mysterious, but it doesn't need to be.
While this is a personal story full of twists and turns,
It's also the story of the science of homes.
join us to unlock the mysterious science of your home too.
In our last episode, it was all about heat, how to make it and keep it in your home so you don't freeze to death. Now, let's kick heat and humidity out of your home so you don't sweat to death all summer long.
Cool and dry is all about air, so we don't have to wade through a bunch of different kinds of machines to do that. But there is an amazing complexity to keeping your home cool and dry.
And here's an embarrassing story to get us started.
Everything we do to and with homes has side effects. Just to demonstrate how easy it is to accidentally detune your home's invisible dynamics, even having all the best products and equipment in the world, we'd like to show you the first cool and dry emergency we had in this, the highest performance tiny house on wheels in the world.
Okay, this was in Delaware in May, and the weather was weird. All day it had been sunny and warm, and we had the air conditioning on. Then the fog rolled in, and it suddenly cooled off by 20 degrees. Anyone might have made the same mistake we made.
I turned on the heat, and this happened. Right now, we're at 77.8 degrees and 62% relative humidity. The ceiling right now is 73 degrees. The walls, also 73 degrees. We're gonna jack the relative humidity way up.
Ew.
Right now, we've hit almost 80 degrees and about 80% relative humidity. So now that the dew point is above 73, everything in this house will start to get wet. We're gonna let it happen because it's beautiful to look at. One time for you right now.
It's important to control our indoor dew point, which, remember, describes the relationship of the air's temperature and humidity to the surfaces touching it. But the other dynamic here is that air conditioners will both cool and dry the air. After it's been running 10 minutes, the cooling coil gets dripping wet, and we re-evaporated all that captured moisture when we switched into heating mode. You just watched our cool surfaces recapture that moisture in the air and turn it back into water. Science.
Moisture affects pretty much everything that happens in a building and everything that happens in the air. The thing that's different in terms of humidity and looking forward for humidity in the future, especially for buildings that are built to the standards that you guys are helping to make sure occur, is that the buildings are very tight. So they don't leak a lot of air, and that's a very good thing. But it also means that air isn't going to escape and humidity is not going to escape by itself. So we have to be a little bit more concerned about humidity than we did before because we're not wasting energy anymore.
On Home Diagnosis, we tend to compare your home with your body. The analogies are usually both interesting and true. So here's another good house body analogy. Your home breathes. It has a breathing apparatus.
There are tubes called ducts carrying air around within your home's skin and to the outdoors, and a fan or a bunch of them powering that air, pushing and pulling it through the ducts.
One way to describe a central duct system is like an octopus. The big air handler fan is the heart, and on one side is the supply ducts that push the air out, while on the other side are the return ducts that pull the air back to it.
And thinking about a central duct system as an octopus is helpful imagery, but it's not the complete picture because the system, like all systems, is really a complete circle. Air is conditioned, pushed out, changed somehow, and pulled back in to be conditioned again. The space in the room between the supply registers and the return grills is an important part of the duct system too.
When you look at it this way, you can start pushing and pulling air using the room arrangements as ducts. This is how we'll manage to never smell the litter box or toilet odors in this house, by being strategic about where the supply and return of air happens.
The studio wing of this house is a long room with a bathroom at one end. And since you know we always need to pull air out of bathrooms, we designed the duct system in this room to pull all the rest of the air from that same end. And all the new air is pushed into the other end of the room.
We'll basically have a weather front, moving air from one side to the other. Now we've turned the whole room into another tool to control the invisible dynamics of our home's performance. It probably won't happen by accident, so remember to plan ahead and design your systems wisely.
A big realization for me when I think about what your air conditioning system actually does. And then I want you to just think about this for a minute. Air has mass and weight. We don't think about that all the time, but if you take a piece of cardboard and you try and lift it up real fast, you can actually feel the resistance of the air. We can feel that the air is there, even though we can't really see it. But when you look at your furnace or your air conditioner, it's actually moving about 30 pounds per minute per ton of cooling. So if you take a home that has 5 tons of cooling, it's actually moving 150 pounds of air every minute through the duct system. And so when you think about the work that your furnace is doing, and then think about the volume of air that has to move through that furnace in an hour and how much dust, all the things that are in your air. And then you think about your body, we're breathing that all in and out. We really need to demand a little bit more of our industry and demand more of the homeowners to start asking for these things, because the first thing we got to do is generate awareness, and people simply aren't aware of the problems or the solutions that exist.
How important is your body's blood pressure? They only measure it every time you go to the doctor. So let's look at the blood pressure of your duct system, called static pressure. You can learn a lot about a system by doing a simple static pressure map. And I'm going to show you that right now. I'm going to need a digital manometer that measures in inches of water column, along with a pressure hose and a static pressure probe. Static pressure is the pressure that pushes in all directions anytime the fan comes on, like blowing up a balloon. Static pressure is more greedy than velocity pressure, which is the other pressure of the air moving down the ducts, like blowing through a straw. Adding these two together gives you total pressure. And the problem is that your fan is only capable of producing so much total pressure. So if we allow static pressure to eat all of the available pressure, then there is no pressure left over to actually move the air to the rooms. This is often caused because ducts are too small or are blocked. We need to measure right before the air handler, which is the heart of every system, and then again right after it. This is where the pressures of the fan are highest, which is why it's so important to have an airtight cover on your filter slot. The total external static pressure is both of these numbers added together. Ignore the negative here. This is a pass-fail test, black or white, because the equipment label always says exactly what the maximum is allowed to be. Probably 90% of the systems I've tested have failed this test. If it fails, we can track down the cause of the problem by moving out systematically with our probes and creating a static pressure map. Then everything becomes clear and fixes to the ductwork are straightforward.
I'm going to go out on a limb here because I'll probably irritate technicians across the world, but we do manual J and manual S and manual D, which are design manuals to help us select the right equipment and help us design the ductwork for the home. But they're little more than an educated guess. Before you do any type of load calculation in a home, you need to understand the most important thing about that home, which is how leaky that home is. And if you're not doing a blower door test, you have no idea how leaky the home is, and you have no idea how to properly size the equipment. A blower door test should be the first test that you do before they actually make the assumptions that they put in the software that helps them with the design. And that's if they use the software. And a lot of technicians don't use the software. They still today use rules of thumb to actually select the equipment for your home. And sadly, it ends up grossly oversized most of the time, which leads to other issues that become a challenge.
I'm building all of the duct systems in this house myself, and we're about to test the first one that I have actually completed. Now, I could feel like I did a great job. I could tell you that I did a great job, but
unless you test it, you don't know if you've done a good job with your duct system.
you're trying to just make sure that the air that is traveling through the ductwork goes where you're aiming it to go and doesn't find a better path of least resistance on the way to the room that it's supposed to be delivered to. We've temporarily taped over the face of all of the openings of the ducts, and actually that tape is going to stay in place for the duration of construction because we're not using the duct system yet, and we want to make sure that no dust gets into our system before we are ready to use it, because it's supposed to be healthy air that we're blowing around. So what we have here is basically a small blower door. We're going to be blowing not this much air. I'm not going to be blowing this much air either. We are going to go with this size hole. Now, if I'm doing a really good job, then later we could try and test it with this hole, which you can't even see. This is my first system, so we'll find out.
We'll see
but
how good he's doing.
the whole point is to know what you're aiming at, right? So we know what number I need to hit in order to meet code in our state. And all states in the US are going to eventually have some standard for testing ducts. This studio is an 800 square foot studio. So there's 8 hundreds in this equation, and 8 times 4, as an example, is
32.
32 is the number that I'm aiming at. If I can get below 32, I pass. If I hit above 32, I fail. That's basically black and white.
And the important thing is your duct system is a lot like your plumbing system. It's basically just plumbing for air. And we want to make sure that all the air is going to the places that we want it to go.
Exactly.
So we were aiming for 32 and you came in at 15.
Making ducts airtight is not rocket science. First time out, and you can do a really good job if you actually are trying to make them airtight. And that's the first step.
So now that you don't have to work on the ducts, you can keep finishing the rest of the house.
Right. I can work on the other 3, 4 duct systems that are in here. So
right.
The breathing apparatus in our house is more complicated than most houses, but we're trying to tell this story, and you'll see how these come together in future episodes.
You just can't see air. People don't think about air. They don't understand that we breathe more gallons of air or pounds of air a day than we probably have any other thing going in and out of our body. And we don't understand how it impacts our health and well-being. So we just sort of ignore it.
If you're not doing any conditioning inside a building at all, no heating, no cooling, no humidification, no dehumidification, the building will sort of tend to collect moisture over time. And if that goes on too long, then you can end up with enough moisture in the materials to support more prolific growth of mold and bacteria. Mold and bacteria are not a problem in buildings generally. There are plenty of fungi in our air all the time. There are even more bacteria in the air all the time. Quick rule of thumb would be people generate about 33 million bacteria per person per hour as their contribution to the air. Then in terms of fungal particles, we stir up a lot and we bring in a lot, and about 7 million per person per hour. That's the problem with doing nothing about humidity over time in a building.
As you crank up humidity, especially fungi become much more active. And so they might have been there before. They might have been slowly metabolizing. You know, you think about a rock that fungi wear down over thousands of years. Well, there's a whole life cycle taking place there that's so at odds with our short lives, but it probably doesn't matter to you. But as you increase the humidity, all of that speeds up, especially for fungi. You're allowing their life cycles to be fast enough to cause us problems on the time scale of our life cycles.
Our TINYLAB has its own dedicated dehumidifier as well, which we resisted getting for a long time, actually.
We toured around the entire country, but then once we settled down, we bit the bullet and got a second piece of equipment.
Yeah, one of the issues is that mini splits, which are the ductless piece of equipment that you see on the wall behind us, don't typically have a great drying potential. Most of these air conditioners are going to both cool and dry, but these are heavy on the cooling. So when you put it into dry mode, you might think that's going to solve your problem. You end up being a little colder than you want to be, and it's still kind of clammy. So the second thing is that we could never park our house in the shade while we were on tour.
We had to put it in the heat of the sun so that we could have the cooling effect from the HVAC.
And then get the drying that comes along with it. It's better to just separate the two and have cooling and drying handled by two independent pieces of equipment.
The other cool thing about a dehumidifier is a little tiny house secret.
We need an off-grid water system here, and so we have drinking water that is in a filtered bottle, and instead of just putting our sink water in, we can take the water that comes out of our air and put it through our filter to drink.
You really do have to be concerned about taking water out of the air for a very large percentage of the time in southern Florida, maybe only 50% of the time in Atlanta, and maybe only 30% of the time in Chicago or Boston, and maybe only 20% of the time in Minneapolis. But 20% of the time in Minneapolis, that dew point temperature is 70 degrees Fahrenheit and above, surprisingly, because it's right there on the Mississippi River and it's soggy there in the summertime. When you are cold in the summertime in a building, that means there's too much cooling. And one of the reasons there's too much cooling is because there's not enough dehumidification. The HVAC engineer, the owner of the building, is trying to achieve comfort without investing in a dehumidifier.
In the crawl space that I made 4 feet tall so that I could fit sliding around here, we have enough room to fit everything that we need to run the house. It's all the engines that are needed. And we have more engines than probably a typical house has. Not because we're going way above and beyond. It's because a modern house that does a lot of modern things needs more equipment, partly because of the air tightness. So behind us here, we've got the heat pump, which is going to do the heating and cooling and a little bit of drying, and a serious drying machine, a dehumidifier that's dedicated for the whole house. They're going to have their own returns. Then we're going to duct them together once they've blown out their conditioned air. If I was to pump this in here, what I've actually done now is taken away any drying ability that this piece of equipment has. So we duct them together after they've conditioned both of their air streams. And that's not something that you'll see in a lot of manufacturers' literature yet. Hopefully that's changing in the next few years. Now, this piece of equipment is a 120. This is the most important metric about a dehumidifier, is how many pints per day it pulls. Remember that the goal of this machine is not to pull water out of air. It is to maintain a humidity level in the house. The fact that we're able to flatline the humidity level, I just happen to find this pretty fascinating. And since we're exploring the science of homes, I thought that I would show exactly what is happening down there. And the amount of air that we're pushing with this is less than 1,000 CFM usually. That's not very much. A lot of homes might have 50% more, 100% more air than that. So the ductwork here is actually pretty minimally sized. Turns out I have a much bigger central shaft than I need. So I'm actually going to be able to build a ladder up through there and get to the top of the house through that shaft if I ever want to. There are other pieces of equipment in these crawl spaces. And remember, we have 2 crawl spaces that are separated. And we will talk about all of these pieces of equipment in the upcoming episodes because, of course, the entire system is starting to come together and we're starting to get a little bit more complex as we go.
For about 125 years, we didn't have the correct values for sizing AC systems from the point of view of humidity control. So when it's really hot outdoors, surprisingly, it's not that humid. It gets really humid when it's a little bit cooler. And so because we're focused on temperature, we choose that for a design point, and we miss about 30% of the humidity load. And that's been true for 125 years until recently. Our handbooks didn't have that information, and now they have it. So because we can see a bigger load, we're spending more time making sure to do something about excess humidity.
Your home is a system, never forget it. So before we start buying and installing machines to cool and dry us, we need to understand the sources of the problem first.
Look where hot moisture is being created in your home first. Kitchens, bathrooms.
Not every home in the world needs air conditioning, but every single one should have exhaust fans in at least these 2 places to remove moisture.
In a bathroom with a shower or tub, there's only one best place to put the exhaust fan.
Over the shower or bathtub.
In fact, the perfect bathroom layout looks like this. Humidity from bathing gets pulled out where it's created. Then, the air coming in under the door to replenish the room grabs any odors around the toilet on its way to the exhaust fan again.
In the TINYLAB, we have a toilet. It's a composting toilet, not like a real toilet. But it pulls air down into it so that even when you're sitting there going to the bathroom, you cannot smell any odors. We wanted to replicate that in this house, although we're not using composting toilets. And there's one right here. The door that you would come into the bathroom through is here, and the exhaust duct is here. What that means is that when air is pulled out over your shoulder, it comes in to be replaced from the door, mostly under the door, and it's going to come up and hit your face before the odors from the toilet are able to come up to your face. So we're able to kind of manipulate the flow of air so that when you're sitting in a specific place, you can smell exactly what you want to smell instead of what accidentally is happening around you, because we put the exhaust fan normally in the ceiling so that all of the fumes are coming up and washing your body in them as they go out. Kind of gross, but it's true and also very scientifically interesting.
You keep that relative humidity at 50%, you are never going to have a moisture accumulation problem unless you have gross water leaks, and hopefully that doesn't happen in a well-built house.
Water vapor is like a teenager. If you stop it from doing what it wants, it's probably going to try to ruin your life. So we're generally cautious about putting plastic into the layers of a home, but
Plastic to contain things like a person getting out of a shower and dripping day after day after day, or plastic on the floor of a shower that is actually going to get probably more wet than the floor of a jungle. The pan of the shower will be wet 100% of the time forever. Plastic as a control mechanism in bathrooms, in places where you know it's going to be wet, is exactly the same thing as putting exhaust fans where you know there's going to be air that you do not want spread throughout your house. Obviously, it's really important to think about how you're going to get the water out from the inside of your house from things like sinks, bathtubs, toilets. Now, this plumbing drain system is not just drains that go down out through the bottom of your house. They also go up. If you think about it, we've got a whole bunch of different branches: toilet, sink, bathtub, kitchen sink, dishwasher, etc., draining down, and they meet up in one line that exits through the bottom of your house and goes to the sewer. But it also goes up to relieve the pressure of that. You have another inverted tree that starts at a bunch of branches that consolidate into potentially as little as one line that goes out through the top of your house. And that's what we were able to do through planning well and making clear that we wanted to try and achieve that if we could. And I literally stopped the team that came in here 5 minutes before they were about to drill a hole through the roof of my house. These guys terrified me. They got done in one day for the entire drain line for this house. The drain line is the sophisticated part. You probably don't want to try that on your own. Water lines, I'm doing on my own in this house, not a problem. But as far as the drains go, they need to be pitched at exactly the right level to make sure that everything that is not wanting to be kept in the house goes out. I think you know what I mean. And where they go in the house is going to potentially interfere, just like everything else, with your enclosure insulation and airtightness layer, and also potentially flashing issues, like, for example, going out through the roof, which I didn't want to do. We were able to actually go out through a wall for the vent at the top of the house. And if you plan properly, you could do anything with any system of your house. But you need to make sure that you have these conversations before you start building. Otherwise, it becomes really complicated and a big, messy nightmare during construction.
I never had a baby room. In the TINYLAB, it's just a baby corner. But with my first, I still dove into all those blogs about baby room must-haves. Good storage for diapers, especially clean and dirty, are definitely essentials. And have you used a sleep machine? They are brilliant for the science of sleep. But one thing on the list that always confused me was the humidifier. Because when it comes to your house, the one thing that will crank up chemistry, microbiology, and smells is moisture. I mean, come on. Every parent has found themselves saying, "Why is this wet?" So that must-have humidifier is really a depends-on item for the baby room, and really any room. You want to keep your home at 40 to 50% relative humidity, and thankfully they make lots of little tools to help you track that. They're called hygrometers, and you can get them for as little as $20. So put that little must-have anywhere in your home before you think about adding humidity?
What can you do about excessive humidity when you don't want to spend money for mechanical equipment and you don't want to spend money for energy? The answer is clothing choices. With different clothing choices and with different comfort expectations, you can do just fine without any mechanical dehumidification at all. And the best proof of that is all of Asia, where until recently, and even today, they really don't care for excessive cooling. We have that habit here in North America. They don't have that habit too much in Southern Europe. They don't care for that. They don't have that habit in Northern Europe. So we can adjust our clothing preferences and we can adjust our expectations and allow the temperature indoors to rise.
Heat and moisture are a big part of our bodies and a big factor wherever we live. If you can learn to tune it, then you can predict and prevent all kinds of headaches with microbes and pests, maintenance, durability, and your family's health.
Now you can enjoy a hot, humid summer, knowing that your house can take whatever the weather throws at it, and still be that same old beautiful haven from the elements. Learn how to tune the science of your home at homediagnosis.tv.
See you next time.
Say hi. Say, I like it.
Home Diagnosis is made possible by support from the Alfred P. Sloan Foundation, by Fantech, Breathe Easy, by Brown-Newtone, come home to fresh air, by AprilAire, everyone deserves healthy air, by Air Cycler, Retrotech, and Santa Fe dehumidifiers, by generous support from these underwriters, and by viewers like you.